That yellow ones. That yellow. Oh, memories and mornings were what's told. They sing me or swing me down into the brine. I hope that wherever you are fine.
Hey Stanford, so, I was just playing around and, I just lost control of this AGI fleet and I'm just trying to figure out what to do. So I came here and I tried to ask Claude and Claude cannot recommend or suggest any activities that would be considered equally as fun as the extremely unethical, dangerous, and potentially catastrophic act of open sourcing as advanced artificial general intelligence. I'm not really sure what that is. Malicious actors, oh my gosh, suffering on a global scale. Okay, so actually the catastrophe is far worse than I imagined. So I made this collar choker in Blender. It took me like 4 hours, and then look at this. I saved this file as ring clothing, and now it's 0 bytes. It's just gone. It's an empty document. So we're gonna have to program an astronaut girl to remake it because I'm way too lazy to do this again. But fortunately,
Astronaut girl, she ventured into the unknown. Her AGI companion, an AI scroll. Graph neural networks, mapping constellations. Intertwined with the music, creating new destinations. A delicate heart.
I recorded everything I did on my desktop as well as the user inputs. So we should be able to just tell her to follow the instructions, just copy what I did, right? Well, there are a few problems with directly copying inputs. First, the virtual desktop might be a different input resolution, although I have control in this case. When we are doing imitation learning from YouTube videos, we're going to have all sorts of different resolutions and operating systems. So we need to be able to adapt to the changing environment context. Since online videos don't provide by default mouse and keyboard input, we can train a simple user interface inverse dynamics model similar to OpenAI. Additionally, we can use speech to text and create a multimodal method by which we convert dialogue into command confirmations. So you can see the user interface dynamics training script here. I use OBS to record. Basically, I run this Python script and it starts recording through OBS and it records all of the input events. And then you can see I have various sessions where I record what I'm doing on my desktop. Now, you can see this is kind of like the format. It just uses a timestamp and what the event is. And obviously it could be in a more compressed format, but this is just sort of a first pass. You can see there is quite a substantial number of events. So it's clear that we need to figure out how we can compress this, particularly compress the mouse movement into more explicitly things like hovering over OCR text or symbols. So we need to take this, million events and kind of compress it to, click on this text, or basically mainly a lot of these events are the mouse movements, and we can't just snap it to one, like a single event, because sometimes hover events are kind of critical for how things operate. And so we need to have we need to abstract this to a higher level. At the first higher level, it's hover over OCR, hover over symbol, and then at another higher level, it's summarizing those behaviors into sequences, which are clusters or singular nodes, which we can use to pathfind higher level behaviors. So I put the keyboard we created in Blender into Unreal Engine so it can be interacted with in a real-time environment by a metahuman. There's still a bit of work that needs to be completed on this before we can have an agent interacting with our keyboard. Basically, it just uses a physics constraint component, and that way the switch can pop up and down. And the keyboard itself is just all these keys laid out manually. Now you can use JSON or try and automate the layout of the keys. However, it's a little bit complicated because also like all the text boxes have to be filled, so you could consider like an editor script or something, but for me the simplest approach was just to manually place all the keys in the right position. Now kind of like what we need to get this hooked up to use a turbo VNC agent is we need to stream video into Unreal Engine, as well as run a plugin script to call a Python server to send the key commands when a key is pressed, and that way we can get the keyboard functional and get a real-time video stream in here. So when we run deep learning text recognition on software like Blender and Unreal Engine, not everything is going to be detected, and there's also going to be cases where symbols are confused with text. And so we need to do some fine-tuning on our deep learning model per software application, as well as use the inverse prefabs and symbol library in order to perform the text-bound recognition. Here, I'm using the symbol anchoring technique to try and track how symbols and text move between frames in order to update their positions without continually running deep learning. So once we've developed an autonomous software agent which can operate Blender, we really need to be asking bigger questions like what sort of things should it be modeling or inventing more broadly, especially once we start to move into hardware, and how can we work on open-ended invention safely. And so I started working on a AI architecture based on future simulation, particularly collaborative multiplayer graph neural network future simulation for autonomous software agents. So first we need to have something that's always running 24/7 at a high frame rate. So we're going to be using video game technology, an entity component system, in order to run a loop for our continual learning agent at a high frame rate. And this way, when we start to integrate graph neural networks to understand what's happening, we kind of have either one or multiple continually running loops.